Is it there? Can you see me?
Hello, gentlemen. Sorry if I have kept you waiting.
No, you are very well in time. It's still 2 minutes, so you are well in time.
Yeah.
Pradeep, everyone has joined. Can we start?
Yes. Yes.
So, can I request Mr. Ole if he can switch on his camera so that I can introduce him?
His camera is already on. He can be seen.
I'm sitting here.
Okay, maybe anyway. I cannot see. It's fine. Yeah, okay. So, I think all others are there, like whatever external people you have invited. Pradeep?
Yes, sir. Yes, sir.
Yeah, okay. So, I'll not waste much of time and let us start. So, it is a great honor for me to introduce and welcome our guest and speaker, Mr. Ole, this afternoon. Ole merely requires any introduction in the European maritime community. He is well known for his work in the field of ship design, ship repair, and retrofits. He has a variety of experience working with design firms, with classification society, working with shipyards and various ship owners. To name few firms, like he has worked with and working with Maersk Line, Maersk Maritime Technology, Caldro Marine. He has worked earlier with Lloyd Register, etc. Besides that, he also does training for young naval architects of Danish Engineering Society, Danish Maritime University, and various other firms with his experience gathered over the time. Moreover, he is profoundly loved and respected by his colleagues, especially the younger colleagues, on whom he has a great influence because of his ability of resolution of any engineering or managerial issues. So, without wasting much of time, I will call upon Mr. Ole to give his presentation on the today's topic. Yeah, Mr. Ole, yeah, you can take over, please. Thank you.
Yeah. Thank you for the very nice words. I'm very embarrassed about such many positive statements. I will see if I can share my screen and then put on the presentation now. And then I will switch off my camera. Can you all hear me loud and clear?
Yes.
Yeah.
Roger.
Yeah.
Yes.
Yeah.
Yes, sir.
Okay. And then I will put on this here. Then I will take down this, and then I will. Good. Can you all see what I can see on this?
Yes.
The presentation here.
Yes.
This is the first slide.
Yes, sir.
Okay, then everything works.
Yes.
I've given this presentation to Danish Naval Architect Society and also to Lloyd's Register some years ago. It was made on the request of Lloyd's Register in order to share the experience that we have had in Maersk with fatigue problems on container vessels through the years. It is, I intend to have this presentation to take around 45 minutes. I'm speaking in English. English is not my mother tongue. I guess the majority of you are not also English as mother tongue. So please excuse if there's something that you don't understand, then please interrupt if there's anything that I should explain a little further. Good. My name is Ole Baston Jørgensen. I graduated as naval architect in 1991. So you can guess I'm not that young anymore. And then I had my first 5 years professional life at B&W Shipyard in the hull construction department. That was a shipyard based in Copenhagen. from 1996 through 1996, I had some temporary employments, amongst others, with Lloyd's Register. And then I joined Maersk Contractors in late 1996 and was there for 2 years working with FPSOs and drilling rigs. Then I joined Carl Marine, which was a Danish consultant house, making designs for European owners building at Asian yards. And then I came back to Maersk in 2003, where I have been since then. The first 2 years I was in offshore, and then since 2005 I have been in with Maersk Fleet Technology, where I work with new building conversions, repairs, and emergency response. Yes, and it is the experience from the past 15 years that I have worked with ship repairs that I'm going to share here. It is practical examples that we face in our daily operation of our 300 owned ship, container ships. And it's an example of fatigue problems. We naturally also deal with other problems, but this presentation is focused on fatigue. Here you see a typical post-Panamax container vessel. I don't know, can you see my cursor here in the picture? It would be useful when I point out things during the presentation. Can you see this?
Yes.
Okay, good. Because then I can use that when I shall explain something. The typical problem areas in the cargo hold region we have, it is mainly in the cargo hold region and also in the interface between the cargo hold region and the engine room that we see fatigue problems on container vessels. The forward end, we have specific problems with slamming and green sea, but that has nothing to do with fatigue. And the aft end problems, we can have some vibration problems leading to fatigue, and also some problems in the rudder hull interface. But this presentation will not focus on this matter. It will focus on the area of the cargo hold and the interface between the cargo hold and the engine room. We have this presentation has around 10 examples. One of the first example is the termination of the longitudinal hatch combing. The hatch combing is, as you know, a continuous member that goes all the way through the cargo hold region, sometimes interrupted in way of the accommodation, sometimes uninterrupted passing the accommodation. At the ends, where as this is the in outmost position of the hull girder, it is needless to say that large stresses will occur in that area. And if you then come to the end of the hull girder, as you see here, and then you taper down the hull girder, it's important that you taper it well down. There are a lot of forces running in the hatch girder, which has to migrate down into the deck structure. Although the longitudinal stresses are not that high in the forward end, they are still considerable. And then when you have the forces coming down here, then you are ending them here, and you have a sharp corner. And then we have on a number of vessels from a specific yard seen a lot of cracks in this area. The way we have dealt with it, and this is a repair I think we have done with on 20 plus vessels, are that we taper down the top flange of the hatch girder. We crop the cracked nose here, and we taper this end well down. We weld this again, and then we smoothen this by grinding and taper this further down. This has solved the problem on these vessels one seldom time we have seen the crack reoccurring, but it is mainly the crack has been caused because you have had a too abrupt closure of this top flange on the hedge combing. That was example number 1. Another example that we have seen on a series of vessels which are more or like sister vessels, more or less sister vessels. It's a series of 20 plus vessels. We have seen specifically in cargo hold number 4, and it's important to emphasize it's only in one cargo hold. On the second deck stringer, not in the upper deck, but the first continuous stringer deck below the upper deck, we have seen cracks in way of the container shelf in this corner and this corner, both in starboard and port side. And we have seen it on, I say again, 20 plus vessels. You can see here, this corner here, you have then turned around, you have the container shelf here, you have the cone for the to steer the container, and then you have the cell guide here, which I have to emphasize is not welded here. It stops around 50 millimeter above the landing pad. And then you can see the crack here developing like this. We have seen that again across this vessel series, and the repair has been quite complicated. The repair has been to crop the cracked, of course, remove the doubler, crop the welding, the cracked plating, and then add an insert of a higher thickness and a higher grade in order to reinforce the area. And then also change the shape of the landing pad so that you get the fillet weld of this doubler away from the high stress area here in way of the deck corner. Here you can see the contour of the original landing pad. Here you can see the contour of the new landing pad. The landing pad is just as efficient as the old one, but then you will get the fillet weld away from the high stress area. And this has solved the problems. The first repairs of this we did back in 2006, and we have not seen any reoccurrences here. It was a poor detailed design, we have to conclude here, where the thickness should have been increased in that particular area. But as you can see, as we have if you have a transverse bulkhead here, and you have a longitudinal bulkhead here in front of the transverse bulkhead. So in order to make this insert, you have to cut holes here. You have to make slits here. You can see here an example of the repair here. Here you still have the landing pad in place. You cut a hole. This is here. You make a slit. You remove the cracked plating. You apply an insert. And then you close it again. As you can see, it's a complicated repair that can only be done. It takes some time to do it, and it's difficult to do in operation. So it is something that we have dealt with like that we have made the permanent repair at docking, and then opened the welding, the crack, and welded it during operation. In sometimes we have done this during operation, but then it has caused us some delays. Third example. This is a European design. The vessel was built in Germany. And here you see the engine room tank top. Then you have the engine room bulkhead here. The engine room here. The engine room bulkhead here. And then you see the tapering down of the tank top into the cargo hold region here in order to meet the height of the double bottom in the cargo hold region. This is quite normal to see this tapering down of the double bottom tank top, the inner bottom, in way of the engine room bulkhead. On top of the ballast tanks in the double bottom, we have a fuel tank, and above the fuel tank we have a cargo hold. Unfortunately, this detail here was poorly designed. As you maybe can see here, there was a misalignment between the knuckle, where you had a transverse butt weld, and then the double bottom floor. And apparently this misalignment was too big, and this knuckle was not well supported. So it resulted in on some vessels, some sister vessels, a leak in the weld because of large stress concentration when the hull was deflecting, leading to that fuel leaked from here down into this area here. And here you can see fuel floating around in the double bottom ballast tank on top of the bottom plating. And here you can see the bottom profiles here. It was quite a mess to clean up. This happened only 2 years after the vessel was delivered from the yard. It was a brand new vessel, more or less. And therefore we initiated a root cause investigation with the yard and with Lloyd's Register, which was the classification society here, and concluded that the root cause was this misalignment between the knuckle here. You can see the tapering of the tank top here. This is a side view, and then the horizontal tank top plating. The repair was done so that the cutout that was in way of this butt weld was closed by a plate, and then we added brackets like this across the tank top. This is a cross section where you have the tank top plating here. You are looking aft, and then you added a lot of brackets connecting between the double bottom girder longitudinals and the profiles, so that we got it well supported here. You can see if you have deflection here, if you have compression here, then the forces will come here, run up here, and then there will be a force, a composant, then also will run in this direction. And it is important to avoid micro deflections here, that we have added these brackets so that this knuckle is well supported. Since then, we have not seen any problems of this nature on these vessels. If you have any questions in order to understand what I am saying to you, please do not hesitate to interrupt. I will. The major questions we can wait till later, but if there is something that you don't understand, you are very welcome to interrupt in order for me to explain further. On the same vessel series as this with the knuckle in the tank top, we also faced some crack problems at the structural interface between the hatch coaming and the accommodation block. The hatch coaming, maybe you cannot see it on this, but this is the hatch coaming that has been taped. The hatch coaming is running here, then being tapered down in way of the accommodation, and then the side of the deck of the deck house is standing on top of the hatch coaming. The hatch coaming is a very, very massive and thick structure, and to grab the forces from the hatch coaming, you have also made an insert in the corners of the house of 40 millimeter thickness. But this 40 millimeter thickness plate is meeting an 8 millimeter plate up here. And therefore, the forces that these 40 millimeter plates are grabbing, then you avoid that cracks will occur in that area here because they are so massive. But then cracks occur when you meet the 8mm plate, because this tapering from 40mm to 8mm becomes so abrupt. After this incident, I learned that on Asian yachts, it's a standard, and also class have the past years started recommending that you don't have a plate thinner than half the thickness of the adjacent plate. And that was also the philosophy that was adapted dealing with this problem, as we inserted a 20mm piece around the 40mm piece so that this met the 8mm. Of course, 8 is still less than half the thickness of 20mm, but it is far better than the original solution, and it's this larger insert was able to distribute the forces well from the 40mm plate here meeting the hedge combing. Again, we have not seen any problems reoccurring in this area here, fortunately. The next has perhaps not that much to do with fatigue, but it's nevertheless a problem we saw on a newly built large container vessel shortly after delivery, and was due to poor design in way of the lashing bridges. I've taken this in due to, although it's not hull structure, but the lashing bridge structure, I've included this in order to show the importance of good details in the design here. Here you see a pad eye for the turnbuckle supporting the meeting the lashing bars, lashing the containers. It is attached to the lashing bridge structure via a doubler here, and the doubler is welded on the side of a square pipe profile with a thickness of limited size. I believe the thickness was around 8mm. And after some voyages, we started facing the problem that some pad eyes were tearing out the wall of the square pipe. And we went back to class that has approved this, and we went back to the yard that has designed this and saying, this is a poor design. What can we do about it? And they made some load tests at the yard, making a model of this, confirming that this was a weak design, because you had a very, you can see it here, you had a very thin doubler meeting this wall here, and this was simply not, then there was a risk that you could, because of stress concentrations here, when forces were pulling in that direction, you had stress concentrations in this area, and then you had a weak spot here with a very thin wall, and then it was torn out. In order not to cut off all the pad eyes and then reinstall them again, we developed a repair procedure where we added a doubler around the existing doubler here with weldings. Here you have the existing doubler, here you have the new doubler with this cutout here, and then this is seen from above, and this is seen from the front, and then you welded it here, here, and around the original doubler so that you had it applied here. And since then, we have not seen any problems. Okay. Case number 6. It's a relatively old design that we see here. And in fact, the same design as where we had these crack problems in hatch number 4 in the second deck stringer. It's the same design. It was the vessels were built at the Danish shipyard Odense Lindø, which was owned by the Maersk Group. So it was, so to say, a little our own colleagues that had made this design, and it's generally a good design that has many of the vessels are still operating in our fleets, although they were built in the late 90s and the early 2000s. Nevertheless, we have seen some fatigue problems. And here, the problem were in the hatch girders. On this generation of design, you had a longitudinal continuous hatch girder all the way through the length of the cargo region in order to support the cargo hatches. We had a side hatch here, a center hatch here, and a hatch in starboard side here. So you had two longitudinal hatch girders running in parallel, which actually was also a part of the took part in the longitudinal strength of the vessel, as was counted in here. And here we have seen a number of cracks. Here you see the top of the hatch girder. You can see here the resting area for the hatch combing here, for the cargo hatch here. And then we faced problems here because you see the forces running here. Here you see a close-up picture, and then you see a crack developing here because of a poor detail in way of this. You have a nose, and then you have cracks, and then it's a damn complicated place to repair. So because of a poor design, we got, I have to say, some problems repairing this because of poor possibility of access. You can see here, there's a long way down into the cargo hold if you're going out here. So it was something that we had to deal with when the vessels were docking. The repair was carried out so that here you can see the original structure with the crack, and then we cropped this part here, this part here, and this part here. And then we introduced a diamond plate meeting to make a soft transition between this structure and this structure. This is seen from the side. And here you can see the diamond plate. Here you see the design of the diamond plate. We increased the thickness, we increased the radius, and we made a proper tapering between this relatively thick diamond plate and the member coming here. And again, I'm happy to say that this solved the problem, and we have not seen this since then. A side note, stepping back to the first example I showed around the fatigue problems that we had in the corners of hatch of the cargo hold number 4. We had a long discussion with ABS where these vessels are classed, and saying that they should do a better find element calculation in order to reveal how long fatigue life you actually have here, because that was not analyzed during design. And they concluded that we would get problems here. It only had a fatigue life of around 5 to 7 years. But they claimed that the problem was much higher in cargo hold number 3. We have seen a lot of cracks in cargo hold number 4, and we have never seen cracks in cargo hold number 3. And that also is a story that tells you that fatigue calculations you can do, but they are built on a lot of assumptions, and therefore sometimes also there is some large uncertainties in these calculations. Because the result depends on the assumptions made. And sometimes designers and class can make mistakes. But that's how we human beings are becoming wiser and wiser. We have to learn from our mistakes. I'm not pointing fingers at the yard. I'm not pointing fingers at the class. It's only so that with the large structures that we deal with, sometimes small mistakes are made that can lead to very costly repairs. And then we have to deal with them the best way possible. And then it's me and my colleagues' obligation to review drawings when we are building new ships in order to ensure that we are not meeting these problems again. And I'm happy that we can also share this with Engine Register, and we have also shared this with other class societies in order to also tell what happens to the ships 10 and 15 years after delivery. Okay, example number 7. Here we are on the transverse stringer decks in the cargo hold region. And these stringer decks, in order to get access to the cargo holds, you have staircases in order to go down to the tank top. And these staircase holes are the thickness of such plating is typically around 10 millimeters. And these staircase holes are rounded in the corners in order to avoid stress concentrations. But the corner radius is kept quite small in order to minimize the size of the hole and provide good access to the staircase. And on some vessels, we are seeing cracks in these areas. We have dealt with them 2 ways. One way was to crop and renew the plating and insert a thicker plate and then increase the radius of the corner. That was a very expensive solution, and therefore I got some complaints from my colleagues in our fleet groups saying, can't you find out a more cheap way to do this repair? We need to do the repair, but if you are going to do it in operation, this is a very expensive repair. So therefore we discussed backwards and forwards, and then we did so that we instead welded the crack plating and inserted a ring, a flat bar ring around the staircase hole like this. Here you can see the flat bar ring. Here you see the stiffener underneath the deck, which is indicated by the stippled line here. And here you can see the flat bar with only 20 millimeter below deck so that you can weld here. And then with a height above the deck. Of course, in way of where you go down the staircase, you cannot have a step like that. So here we have tapered it down like this. I have not heard that we have seen problems after this repair. Sometimes it's not that much that shall be done in order to reinforce, and then you solve the problem permanently, because you go from 10-year fatigue life to 50-year fatigue life, because you improve the strength considerably. Again, also here, an older container vessel with a design solution that you would not see in modern container vessels. This vessel was built in the 90s in Japan. Here you can see again a stringer deck platform in the cargo hold. You can see the rounded corner. It is a little the same as the first example. I mean, it's the same area. Sorry, there's a big echo right now, so someone has turned something on, so I cannot hear what I'm saying.
So Mr. Rashid Kapoor, keep your mic on mute.
Okay. You have the stringer deck corner here. You have the cell guide here. And then you have attached a support for the cell guide. Of course, the cell guide needs some support because it's a very long profile. But then they attached the cell guide at the position where you have made this large corner radius in order to make a smooth transition of the forces coming from the longitudinal stringer deck into the transverse bulkhead. And of course, this 90-degree, very sharp corner totally ruins the intentions to smoothen this area, because now you get a very large stress concentration here. And needless to say, we got a crack here. And the repair was cropping and renewal of the plating, and then make a cell guide support underneath the stringer deck, so that the support of the cell guide was independent of the stringer deck. That solved the problem. Again, here you have a transverse bulkhead. It's a feeder vessel. It's a feeder vessel, a smaller container vessel here. You have the stringer deck in a transverse bulkhead, meeting the inner shell here. Then you have a ballast tank here. Then you have a plate insert here. You have the longitudinal profile here. And then you have a bracket here, an intercoastal bracket in both sides. But the I guess it might be the as you don't have a full stringer deck here, but a full stringer deck here, then when you get deflections in the hull, potentially I think it must be torsional deflections, then you get stress concentrations at this area and this area. And this resulted in cracks on a number of sister vessels in this area, and we solved it by, let's go back again, by cutting off the nose of the bracket here in both sides, and then apply a new larger bracket with a larger radius and a very small nose here. And and that's again solved the problem, because you smoothened the stress concentration by increasing the radius. The last story I've added since I did the presentation to Lloyd's Register. Actually, I added it this morning. It is a case that we have had on 4 different container vessel designs built at the same yard. Again, it's container vessel designs of different size with a number of sister vessels in each vessel series. It's 4 different designs, but they all have the same layout, where you have a here you have the aft deck, here you have the accommodation block, and then you have the engine room underneath the accommodation block, and the engine room is also positioned underneath the bay aft of the accommodation block. And in order to maximize your intake, you have avoided to have a hatch here. You have just said all containers are standing on deck, but in order to get an extra tier of containers, you have made a sunken deck at this position. So actually at this sunken deck, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 tiers of containers standing. And as you can is indicated on this is taken from the general arrangement. You can see that the vertical position of the horizontal deck does not match the vertical position of the second deck in the engine room. At the forward end of the sunken deck, here you have the bulkhead. Then you have some brackets, transition brackets from the horizontal plate here being the sunken deck, in order to transfer stresses from the deck into the longitudinal structures in the engine room. And here you have the bulkhead. And we saw a number of cracks here, and that was a big problem. Because here you are standing in the engine room, you are looking up at the sunken deck here. Here you can see the longitudinal members coming in here. And here you have the bulkhead. And on the other side of the bulkhead, you have the engine control room, where all the hull structure is covered by panels. And you have the sunken deck being around this position here, the horizontal blue line. And then you have these longitudinals meeting here, here, and number 21, I guess it must be here, something like that. So, as you can imagine, it was not a good place to be to repair. And as these vessels were quite young, around 5 years when this was discovered the first time, 6 years perhaps, we had to deal with it. And we went back to class. A part of these sister vessels were classed with Lloyd's Register. A part of these sister vessels were classed with ABS, and they both made together with the yard, who was very engaged in solving the problem, made a reinforcement proposal, or and then we adapted the reinforcement endorsed by Lloyd's Register, because it was more massive than than ABS's. Not saying that the ABS's did not have sufficient strength. If you get to give two persons a task, they solve it in a different way. But to be on the safe side, because this was a very expensive reinforcement that we had to do, we chose the most robust solution, being the Lloyd's Register in this case. And as you can see here, these brackets here were reinforced by other thicker brackets and intercoastal brackets in this area here. And we also had to do some reinforcement in where the girders met the bulkhead. I've not included details of this here, but there was a lot of patchwork with thicker inserts that had to be carried out, and this could only be done during docking. And it is because we are still doing these types of repairs. It is a quite expensive repair to do. And again, this is an example of, if you have had the eye on the right spot when you designed it, you could have avoided the problem. I'm not saying that the yard made a poor design and class neglected a potential problem, but sometimes there are some things in a ship design that you don't see, and then you have to solve the problem. And needless to say, we are doing our utmost also when we do drawing review in Maersk, in order to share our experience so that we improve the designs for the next generation of vessels. Again, this was a design solution on a big yard, one of the world's largest yards, which we saw on 4 different vessels and vessel series, and we have had problems on all 4 different vessel series. That was my last example that I wanted to share. I could dig out a few other examples, but I'm happy to say that these covers the most typical fatigue problems that we have seen through my career in the department where I've been sitting the past 15 years. And then I show you a nice picture of a nicely painted bracket where they did not manage to crop and renew the corroded bracket. But it's nice paintwork. Then I'm open for questions. And again, thank you for taking the time to listen to my humble experience.
Ole, you can, we would like to see your face now.
Yes,
So
yes, I will put it up again if I can do that. You know, this is these good. And then down.
Light.
Yeah, and then I will see if I can.
So, Mr. Sir, like we will give first preference to the field surveys for the questions.
Yeah, just a moment. Just a moment. Can you see me?
Not yet.
No, I have some problems getting it online here. Yeah, here you are. And then I will, okay. Sorry for that. Can you see me now?
Yes, we can see you.
Actually, on top near your microphone, there is a box written into. You can cross that so that you will unshare. Now you are sharing your desktop. Just by the side of leave, there is a square box with a cross. You click that.
Sorry, if that was a question, I could not hear what was said. Sorry for that.
Pradeep just explained, no? Leave ke baaju mein one square box is there. He can unshare. He's still sharing his desktop.
Ole, can you please unshare your screen? Can you stop sharing your screen?
Yes.
Yeah, that.
Sorry. Yeah.
Yes, that's it. That's it.
That was better.
Sir, we are giving a chance to the field surveys for the questions. Field surveys, I mean output. Arvind?
Yes, sir. This is regarding the case 6, which we discussed about.
Arvind, just introduce yourself, you know.
Yes, sir. Ole, this is Arvind. I've been a marine engineer for 12 years and ship surveyor for around 6 years now with the Indian Register.
Yes.
I've done new buildings, I've done retrofits, and now as a ship surveyor with Indian Register and posted here in Houston. I was very much interested in the case 6, where you told about inserting the diamond plates instead of the triangular plates.
Yes. Yeah.
Yes. And I believe this, instead of keeping it as a localized thing, we should keep all the diamond plates towards the center, where we always think that the load is a uniformly distributed load, but actually the load is never uniform. So we should keep all the diamond plates in the center, the triangular plates or something like an equilateral triangular plates, pad plates in the middle, and the right angle triangles at the ends. I guess this should be a pattern which we should follow, where there is more mass in the center. This will add stiffness to the system.
Yeah.
Arvind, if you can show the paper again.
Yeah. Again, I'm not sure if I understand the comment correctly, but this we made this reinforcement here. We made a triangular diamond plate, and it was not possible to make a square diamond plate, a 4-edge diamond plate, because the member coming from above was not at the same level as the other. Then the repair had been more cumbersome. But again, I think the central thing is that diamond plates are a good thing when you have members crossing each other's, instead of a bracket that meets a flange with a nose on. If you could describe this a little further, your thoughts around, I would be very grateful if you could share it. I will send a PDF of this presentation afterwards, and then your comments would be very much appreciated, and then we could perhaps continue the correspondence in writing. That would be fine.
Sure, sir.
Because
sure, sir.
I also hope to learn something from this discussion here.
Sure, sir.
Yeah,
I'll do that.
Yeah,
I'll leave the stage for the next question.
Sir, sir. Yeah. Ole, like we had a question from the plan approval.
Yes.
Not me, of course. If I ask a question, like it'll be bad. I was working with you.
There's no silly questions, only silly answers. So
Yes,
just answer. Just ask your questions. Okay.
Yes. See the insert which you put right on the corner crack, right? The 25 mm EH insert by cutting the bulkheads of. Arvind, you want something?
I guess you're discussing about the case 2, where the fillet weld was taken away and he had put an AH-36 reinforcement. Was
Yes,
that case
by cutting off longitudinal and the transverse bulkhead.
Yeah.
Yes.
Yeah. So the query from the plan approval is that how is a new design? Let's say triple E and other things. Are they coming with this as a ready-made or patchwork?
It is on new designs. You see, actually already at the next series we had from the same yard, because we had a series of vessels with a new design made with the same main dimensions. They had increased the thickness and the grade in that area, and we have never seen problems of that nature on these vessels. So it's very often that you have a patchwork in that area where you have, for instance, 15 millimeter for the stringer deck plating, and then in way of the corners you go up to 25 or 30 millimeter. Again, here it's important that you don't step up in thickness more than double the thickness of the stringer deck, and that you have the butt wells a little away from the corner, so that you don't then get stress concentrations in the butt weld between the thinner and the thicker deck. In some seldom cases, we have seen then that we, instead of having cracks in the corner, we then have cracks in the butt weld because you go from the step in thickness is too large. But on the modern designs, yes, we normally have what you could call a patchwork, where you have thicker inserts in way of the stringer decks. Especially now, it is not only especially in the forward end, also in the midship area. But for some reason, the problem is always in the around the foremost quarter, where you go from the midsection to around the foremost quarter of the cargo hold region. And I don't know if it has something to do with the flare of the vessel, and then the change in cross-sectional properties of the hull girder, and then perhaps waves hitting, giving some torsional moments, torsional moments in the hull girder. I don't know, but yeah, okay, that's perhaps your plan approval can answer that a little around that. But yes, it's a patchwork today.
Yes, the next question from the plan approval again is about the hatch opening, the access opening to the horizontal stringer, access opening.
Yeah.
I forgot the case name. Basically, there were two repair options. One is locally increasing the thickness.
Yes.
Or we are actually having a edge ring, edge ring or edge stiffener.
Yeah.
So the question from plan approval is that when we did this local increase of thickness, the radius was maintained same, and when you did the
It's my philosophy then, if you a case where you have to do cutting and welding. It's a very expensive exercise to prepare for such job. So therefore, when you have decided to do the repair, you can just as well do it as solid as possible, because then you can be sure that you are because if you optimize the repair too much, then you can get new problems, and then my operation would be on my neck and giving me a hard time. So therefore, if you are going to cut and weld, then you can just as well make it fat and juicy. And in this case, I increased both the radius and the thickness of the insert compared to the original. The other, you could call it the discount solution with the flat bar, actually showed to be a good compromise because it solved the problem. So sometimes then operation comes back to us and say, well, couldn't you make it a little less expensive? And then you find a perhaps not the gold-plated solution, but a better solution. But yes, normally if we are going to cut and weld, then if we have the possibility also to increase the radius, then we do that. But it's not always possible.
Yeah, thank you. Any more questions on plan approval? Yes. Yeah, the question is from my first boss, Mr. Dr. Samanda. He is my first boss in IRS. He is into structural design and fatigue analysis. He is also postdoctoral fellowship. The question is that you had been mentioning that one particular cargo hold, that is number 4. What could be the probable reason? Why this number 4? Why this jinx is on?
I touched upon the subject a little earlier. That sometimes it's a poor, some factors going together that gives a bad situation there. But I guess it's because that you have this combination of longitudinal stresses, torsional stresses, which are higher in the midship area, and then at a position where the cross-sectional properties decrease, both torsional and also in bending, because of the vessel going from the more or less square section in the middle to a triangular section because of the flare and the hull shape. And then cargo hold 4 seemed to be the place where it was the stresses were highest. And again, ABS said to us, you will get more problems in cargo hold number 3. And I can only say we never saw problems in cargo hold number 3. So that also tells a little about the uncertainties that we sometimes deal with when we are trying to foresee the stresses that these vessels are subject to. On future designs, we also reinforced in way of cargo hold number 3, but on this vessel series we never saw cracks in that area. So that might be because that the bending stresses and torsional stresses are lesser in that area compared to cargo hold 4. It's the combination that is different, and it can be difficult to calculate, because you build a lot of the assumptions that you made in your load cases.
Dr. Chamanda, does it answer the question? Mr. Tapesh Ghosh, he's a marine engineer, and he is actually head of type approval of engines and components, and he has a question, sir.
Very layman question. What I am more interested to know, when we are doing such repair, are we calculating anything, or we are just guessing and putting a thickness of it?
I did not hear the question.
I can repeat for you. He is actually challenging all the naval architects.
No.
Yes.
So he's a marine engineer. He has got a little bit of issues with this. So when we do the repair and when we increase the thickness and the radius, what Mr. Ghosh is asking is that, are we doing any calculations? A plus B square? What?
No, I just say, well, if it's a 15 millimeter plate cracking and you see it's a fatigue crack, then you say 20 or 25. It's perhaps if you put in the new insert, it would take, if it's cracked after 7 years and you put a new insert in that has the same thickness and grade, then you can expect it to crack again 15 years from now, 7 years from now, the same time, in theory. But it could be that the loads will be different because it changed the waters where it's sailing. But in order to be on the safe side for the rest of the lifetime, then you just say, instead of 15, go up to 20 or 25. And again, I do not have any tool to calculate it. If I had, it will build again on assumptions, and then there would be some uncertainties. We have to be honest to ourselves, because in school we learn that we can calculate everything, and then we put 2 lines under the result, and then there's only this one result. But when we calculate on fatigue and structures, there are large uncertainties, and then you have to make your judgment and say, well, and sometimes we choose the thickness and the grade also, of course, in dialogue with class. Class is very interested also to have our input and hear our challenging questions in order for them to develop their expertise. But again, I do not do the calculations.
Yeah, the answer is there is no calculation many times, but we have seen the FEM analysis on the slide, which was an extensive calculation. It's not straightforward, which was done only because of a design change. Mr. Gosha, is it okay? The answer?
Yes.
Yeah. Sir, Mr. Abubakar, Mr. Abubakar, like he's also representing many various forums in IMO. Please come. Please.
Yeah, thank you, Pradeep. Firstly, this is really in continuation of what Mr. Tapesh Ghosh has told. What I have experienced, whatever you have presented is, firstly, it is intuitively very, very appealing. And I really appreciate, because everything, being a professional naval pilot, I can appreciate all those very, very intuitively. But as he asked about the calculations, I remember one incident in Greece. There was a course on fatigue analysis was held by BMT, and that time I had to do some amount of fatigue calculations. And then one Swedish gentleman, he told, Apurva, whatever calculations you do, where it is supposed to crack, it will crack, and it doesn't depend on your calculations. Because you have rightly pointed out, because there are so much of uncertainties in the calculations. I think the approach which you have taken, sort of a best practice, and I think earlier I saw about 10 years before, IX has published one nice guideline with a lot of pictures about the good practices to avoid fatigue. I think that is a sort of a more effective way of improving the quality rather than calculations, because really speaking, I'm not big authority in fatigue, but even the fatigue calculations procedure, when I look at it, it doesn't really convince me personally. See, wherever there is a stress concentration or the higher stress, fatigue is likely to occur there. But after that, when there does the fatigue calculation, and when we know the cyclic loads are coming in certain areas, we know intuitively where it comes. And also from the service history, as you have collected a lot of information, service history, that also gives a lot of information about where the cyclic load is actually likely to come. And then possibly, as I have said, that you provide a lot of feedback to the class societies to possibly calibrate their software, rather than software telling us what to do. It is actual service history feedback to the software to calibrate the software. So what my personal view is, the calculation methodology is still not so developed that we can really depend on that and rely on that. That is sort of my personal view. And whatever approach work you are doing, that is actually useful practically to improve the fatigue. Because all your proposal which you have said is very, very, I can appreciate it. I can intuitively really convince myself, yeah, this should be the way. That's what my submission. Thank you.
Thank you, Dr. Abubakar. Any more questions from the youngsters?
Could I say something?
Yes.
I very much agree to the comments just raised here. In my career, I worked with new building the first 10 years, and then I have worked with repairing vessels in operations for the past 15 years, almost 20. And I can only say that, yes, you can calculate something and you can design according to class rules, but what is important when you do your plan approval, and you do plan approval, we also do plan approval on the from the view of the owner. It is important to look into and calculate, and here we rely on class, but it's also important to look at where can things potentially go wrong. And as a classification society, I can only encourage you to establish knowledge sharing between your field surveyors. I guess you're already doing so in a structure, but establish a good knowledge sharing between your field surveyors and your plan approval, so that you in your plan approval office establish an eye not only to look at the scanlings, but also to see this detail looks that it can invite to problems. And then as a plan approval officer, then make a remark on this and say, although it's fulfilling class rules, then say this detail could be better because we have experienced that these type of details are prone to crack. That I know this IAX guideline on container vessels designs, and also when we had tankers in our fleet, I was participating in the Tanker Structure Cooperative Forum, where I believe also Indian Register is a member. And there was also a good exchange of best practices. And it's important that your young plan approval colleagues gets introduced to this. It's important that they learn the class rules, of course, but it's also important that they learn about the best practices. Yeah.
Yes.
Sorry for the long comment.
Thank you, sir. Yeah.
So I think there are more questions, or we can generally.
If it is there is one more time, I think is I have one point, Mr. Mishra. Is it possible?
Just 1 minute. May I know who this is? May I know? Muhadir, 1 minute. I'll put you on spotlight, please. I'll put you on spotlight.
Okay.
Please switch on your camera, please. We would like to see Muhadir. We would like to see your face, sir. Hi, how are you?
Yeah. Good. Thank you. Okay. I think I'm the last question. Thank you, Ole. A very interesting presentation. I think are you still able to show the presentation, Ole? I think no. Yeah. Anyway.
Yes.
Okay. Not much. I think I still remember. There are a few points. Is interesting case that you highlighted. Let me select two cases, which is very interesting to know. I take one case, if I still remember, is a crack on the hatch corner bracket 2. Is it right? Yeah, that is you increasing the thicker of the hatch corner, and then you make a taper. I still remember this one. Okay,
Yeah. That was not the hatch corner, but the stringer deck. Yes.
Yeah, stringer deck in the N2 of the bracket. That is, we make snapping and then smooth the two in the deck, main deck, right?
Yeah.
And then the solution is increasing the thicker of the original plate. Is it right? If I remember well. Yeah.
Oh, okay. Yeah,
Okay.
I get it. That was the first example. Yeah.
This is that is we have done practically in the previous class we done also. But one is interesting issue that in this situation, in the big picture, how is the situation of the another vessel? I mean, we have produced the vessel, similar vessel, a series vessel. That is whether we have to recall, because this is something that design issue. If we identify and we arrive in the week of this corner, we have to increase the thicker of this one. Then the problem comes then how is the vessel is already delivered, which is similar or a sister ship series. It has been cell. How is discussion of this cell? Any motivate to recall, or this is the first question.
Okay, you are talking about how we are handling it. If you see the problem, and then we have a number of sister vessels with the same design.
Yeah.
Yes, you cannot change. You can of course not change the design because all 20 vessels are built. So then we say to the fleet groups which are undertaking the operation of these vessels, tell your vessels to watch out for this detail. And then we get and inspect the detail now. And then sometimes we make an Excel sheet with all the vessel names, and then we can say these vessels have problems here, these vessels have problem here. Then we establish an overview, and then we also get an idea how severe this problem is. Because very often when it's fatigue, a sister vessel, or perhaps many sister vessels, have seen the same problem without knowing it. And then we plan for permanent repair on all the vessels, of course, with proper consideration to our operation and the tight schedules that our fleets are going to fulfill.
Yes, correct. That is the okay. And also the issue is because we have to increase the thicker. There is some can be. If the owner said that I already the design is already approved, but I still to increase there is economic aspect there, but this is a small issue. Let me take the second case.
Okay. Yeah, just one comment here. We normally do not say to our fleet groups that they should reinforce if there's no crack. If there's no crack, then just leave it and inspect it on regular basis. And then if you get the crack, then you can repair like this. We normally do not say to 20 vessels, repair in 4 positions now. That would not give any meaning. But if you get a crack, then the repair is like that.
Oh, okay. We can understand this is monitoring and watch stage.
Yes.
I mean, it's not in generalized. So okay. Let me take one more case, which is quite interesting to me. I think is case number 2, which is there is a misalignment between taper plate between the engine room inner bottom to the going to the inner bottom of the cargo region. Is it right?
Yes.
As I remember well, you said that this is the misalignment issue, right? Or a design issue.
Yes. I see if I would like to see if I can share my screen again.
Yes. That is, I think it's better you say because it's a big
How is it going now with that? Can you see the
we can
slides?
see your screen. We can see your screen.
Yeah, okay. Then I will go down to the example here. Just a moment. It was too long.
Yes.
Yeah.
Yeah.
It's case number 3.
Yeah.
Yes. The problem was that you had this knuckle, which if I zoom in just if you had sorry gentlemen,
No problem.
you have this knuckle here, and then if I don't know if I can remember if it was 35 millimeters from the butt weld and to the floor, and then there was no supporting member at this area, and then you had a cutout, and this butt weld was quite unsupported, and then when you got compression forces, the forces have to go around this corner here and then through this corner, and when the forces are running through a knuckle, then there is a composite also going out of plane here, and that causes this some micro deflections in this area, and therefore we had to close this plate in order to make some support at the crossing, and also close the cutout in order to make support at the crossing, and then add a bracket here meeting the knuckle, so that you got a very, very stiff butt weld connection here. And that solved the problem. But it was this vessel was very, very deeply analyzed and had all kind of fatigue notations from Lloyd Register. But you can put all kind of fatigue notations and make many calculations. If you don't look at the right area, you will not discover it. And having these fatigue notations does not take away the designer's responsibility to make good, sound design solutions. And having a gap of 35 millimeter between the knuckle and this floor here is not to be considered as a good solution. At least not in this case. It proved to be a weak solution because you had cracks on a number of sister vessels within the first 2 years after delivery of these vessels. And but the fatigue analysis did not catch this because it focused on other details in the cargo region. And therefore, to catch this, it had to take that either the designer at the yard had done his homework correctly or had the right skills to see that this is a poor design, and also the plan approval. This is a good case of where also class should have made their plan approval engineer able also to not only look at the fancy color plots, the fatigue calculation, but also say this detail invites problems. And here, again coming back, it's important that you have a good dialogue between the field surveyors and the plan approval, because it's the field surveyors that see the problem 5 and 10 or 50 years.
Yeah, Pradeep, I think we must finish now this question and answer session.
Yes.
Yeah, okay.
Yes. Muhadir, what I suggest is that, we have Ole with us. Anytime we can email him or email me, I'll forward to him. I can collect and send it to him. Right now, I think we should let Ole go because he's a busy man, right?
Yeah, so
Yeah.
just, yeah. So, I mean, On behalf of Indian Register of Shipping, I extend a very hearty vote of thanks to you, Mr. Ole, for sparing time from your busy schedule and for giving this presentation on challenges in container ship repair and design modification and covering the basically fatigue cracks in cargo hold region. And we had really had very lively interaction thereafter in way of question and answer. So thank you once again, and we would like to have interaction in future as well. So thank you very much. On behalf of Indian Register of Shipping, I would like to thanks to you. Thank you.
I would also like to say thank you.
Would you like to say something before you go?
I would also like to say thank you for inviting me. It's always inspiring to share knowledge with colleagues around the world, and especially with the class societies. I will make a copy of this presentation in PDF format and share it with Pradeep, and then he can distribute it to this. And should there be any questions coming up, please send your questions through Pradeep. Then I will try to answer them as best way as possible. I could also learn from that discussion, so I would look forward to that. Thank you very much.
Thanks a lot, and nice having you here, and we'll be in touch. Yeah.
Yes.
Thank you, Ole.
Yeah.
Bye.
Thank you.
Best regards from snowy Denmark here, and
Yes.
have a good evening.
Quite cool here. Yeah. Thanks. Bye.
Bye.
Thank you.
Bye.
Bye. Thank you, Ole.
Bye.
Thank you.
Thank you, sir.
Any colleagues staying back? No, we can always have a discussion on this or similar sessions. Arvind, you seem to be very much interested. Muhadir is very much interested.
Yeah, because as a class, we are also supposed to be a solutions provider, right?
Yes. No, what we had is, we had a similar session in Cochin when I was in Cochin, and so I was actually, probably south and west, and it was not very much organized. Mr. Sheshadri Raja, he's here. Would you like to comment on something?
For case 5.
Oh, yes.
The pad plate design, I believe the other pad plates we can leave as a primitive design or something like that, but where container lashings are used, or if it is for a container securing arrangement, then I guess we need to distribute all the loads just outside of this square pad plate. We might need to take a few webs, like we have the main engine chocks, where we have webs on both sides, or maybe on all 4 sides, where we put resin and we put these web kind of chocks at the base. So I guess for containers, there are a lot of loads because of the acceleration, because of the rolling and other dynamic forces are there. And there is also a constant force where the turnbuckles are continuously kept tight. And it's like you put a already flat constant load and a sinusoidal wave on top of it. So the load is going to be higher and fluctuating as well. So it will increase the fatigue failure, maybe accelerate the fatigue failure as well. So for the container pad plates, where the turnbuckles are going to be fastened, I guess we need to reinvent the wheel, I believe.
Reshape the pads. Yes, reshape the pads. And I just there was a question from Plan Approval, whether they are doing it on the new vessel or not. But unfortunately, what happens in Hyundai, you've been in Hyundai and any place. See, if it is Indian yard, I can just change my design just like that without telling anybody. Okay, but Hyundai, if I'm to do the design change, it is a big bloody process. Okay, so and they will not accept it. Okay, I've seen a pipeline going through a door. Can you believe it? And it was okay because the pipeline and the door guy was not coordinating. Understand? And he just opened the door and let the pipeline through that. So Korean yards are much more disciplined than us, but sometimes they lack. Marine engineers are interested in hull repair. Most of the time, I get a comment here. Naval Arc is like a dabba banane ka kaam. Dabba. what is that? Dabba banane ka kam. I'm not very good at Hindi, but if you see the Maersk line, like they basically after getting the plan approved by Lloyd's, they do a thorough approval on their own. If you see Great Eastern, which is the biggest company here, man, I don't think they have that kind of thing. If you see SCI, I don't see they just sit and do something else. That's the thing.
Basically, Maersk has realized that they might get cheaper ships at shipyard, but then later maintaining it in the dry dock and every subsequent special surveys and intermediate surveys, it costs more. So it is better to nip the crack right at the source.
Yes.
So that's what they've realized now.
They spend a lot of money on basically research work on their own, so that their vessels are safe. If you remember, there is a vessel called Maersk Honam, Honim. When I was in Maersk, that is the only emergency I dealt with when I was in Maersk. All this crew was missing. Right? They were actually not even ash was there.
Was that the one which got fire in the Suez Canal?
Not I'm not sure. It is called Maersk Honam. It is quite a famous thing, and they had to cut the vessel into two, and one vessel was taken to dry dock, Dubai dry docks, and the forward port had to be towed to somewhere else and scrapped. And forward part was actually under guarantee, and it was made by Korea and towed away and all that. So I was doing calculation. I also have a presentation for that as well. Okay, so if this presentation from Ole is interesting, we could have very regular sessions, at least once in a month, in a good time.
That's fair
but
enough.
I would only say, Arvind, you take care of your timing, and we are flexible. We are flexible.
No. If there are 100 participants, only one participant has to sacrifice. I'm glad enough to make that sacrifice.
We are Jesus Christ. We leave all the sheep. We are actually leaving all the sheep to save one sheep. No problem. We do that. Yeah. So I think we can, kind of, let's say, pack up for the day, and probably when we come back from Gujarat with this container vessel experience, we can share more. And if you have anything specific, you can always write back to us.
I would like to have something to add with the FRP boats also.
Yes.
Because nowadays a lot of FRP boats are being made, and
you want to know the construction and or the plan approval. How is it, sir? What do you want to know?
Yes. No. Construction part, plan approval part may come later, but as field surveyors, more interested in the construction part.
Most of the field surveys in IRS, they see the YouTube and go to survey. So which is again not a good thing, but I think that feedback is already gone from Mahindra. Mahindra.
Something is better than nothing. Something is better than nothing.
Yes. But I'll tell you what, if you see that way, then we cannot be gods. So something similar happened in Mahindra, the Anand Mahindra's yard. They were making a very good, recreational boats, and our surveys basically couldn't actually deliver it on time, and there was a feedback. So I think there's an FRP training coming in, sir. Yeah. Yes. What is the time, Arvind, there?
It's 5:30 in the morning now.
Oh, you got up very early.
Yeah. That's fine.
Yes.
So we should continue this maybe at least on a monthly basis, or as a minimum quarterly basis, where some amount of knowledge sharing is done.
Yeah, I suggest, what I'm suggesting, I'm all open for it, and I like talking, and I like to interact. And if it comes from an output, this want, and it will be taken seriously. Okay.
Yeah.
And head of operations, he takes it very seriously, then I actually have an edge. Okay, I can start something, So that's the idea. If you can give us in writing, okay, we need this, you got it.
Oh, sure. Yes. I'll try to put from my side for sure.
Yes. And also, if you think that there are some design changes which you actually could propose, I'll share the PDF with you, and also the recording will be available soon. And if you think that there are some better designs, and you have some designers there, we can always share to Ole. And he's a very open man. You see, he's a naval arc, but he is open to any kind of suggestions. Yeah, I had a tough time with him. Let me tell you. First 2-3 months I had a tough time with him in Maersk, because
tough time is good.
Yeah, tough time makes what you call strong people, and easy time makes stupid people. That's what I think. So I had tough time, and 3 months, and rest 4 years I enjoyed. That's it. Yeah. So Sangameshan sir, Raghuram, where are you? Raghuram.
Goa. He's in Goa.
Anybody from Gujarat? Any help? Any taxi? I want to arrange a taxi. And I also want a boiler suit and shoes. I want something,
Okay,
I'll take
Pradeep, thank you very much for the
yes.
presentation. So we
Sir,
should
I'm
have
coming to
more
Colombo. I'm
interaction
coming to Colombo
between-
Dockyard. I'm going to Colombo Dockyard to give them some training in design. So probably
Yeah.
I'll meet you. I think you're staying in my house, right? In Colombo, where I was staying.
Yes, really.
Yes. I'll see you then.
Seamless.
Yeah. See you then. Yeah.
No,
Bye.
I'm asking is when
Yeah.
you are planning to come? What is the
Maybe after March.
plan?
Yeah.
Okay, come back for a longer stay so that you can do some surveys also.
Yeah. I can get requalified. I'm a
Yes.
secret surveyor, I'm a secret surveyor even in IOPP. Okay. So I'll reinstate that. Yeah, thanks. Yeah. Thank you, Arvind. Thank you, Sankar Masurin.
Thank you.
We are the last one standing. Thanks a lot. Yeah, thanks. Bye.
Bye.
Bye.